a few aspects which are important for integration for these entrance examinations. First up, it is normal integration, right? Like integration of x to the power n. This is what each of you should know, which I'm sure all of you do. What is integration of a to the power x? So basic formulas of integration, this will come in handy. A. B. Integration by substitution. Okay, this is going to be handy. An example of this would be if I have an integration, suppose 2x by x square. Okay, you take u is equal to x square. Okay, so du will be 2x dx. So 2x dx is equal to du. So this can be written as du by u, which can be written as log u plus c, which can be written as u was x square. Correct? So this integration by substitution, where I substitute another variable for some function of x. Okay, so here what am I doing? I'm substituting a variable for some function of x and then finding out du as a result of f dash x into dx. Okay, and then I substitute this as well in the integration and then find out my solution. Okay, part C, which is important for these entrances, will be integration by parts. Okay, so integration of u, which is a function of x, v, which is a function of x, dx. I will write this thing down in this way. I'll call u as the first function and I'll call v as the second function, and I will be able to write down the integration in this way: u integration v dx minus du dx integration v dx whole dx. Okay, so this is integration by parts. Okay, right? So how to choose the first and the second function? We have a guideline called ILATE, where I stands for inverse, L stands for logarithm, A stands for algebraic function, T stands for trigonometric function, E stands for exponential function. So we usually follow this order for the first and the second function. So if I have an inverse and a logarithm multiplication, so u is supposing an inverse, v is supposing a logarithm, then I will consider the inverse first and then the logarithm. So inverse will be the first function, logarithm will be the second function. What is inverse of a function? Sine inverse x, cos inverse x. These are all inverse functions. Logarithm is log x. Algebraic is any function of x, like a to the power, sorry, not a to the power x, any function of x like x square, x cube, right? These are all functions of x, which is the algebraic. Trigonometry will be sin x, cos x, tan x. Exponential will be e to the power x, a to the power x, so on and so forth. Okay, so we consider integration by parts in this particular fashion. Okay, next up we have integration of box function. This will be completely new for most of you, if not all of you. This we'll do it in detail in a while. So box function, how to deal with box function? So firstly, you need to understand what is a box function. What is box x? Box x is basically the greatest integer less than or equal to x. Greatest integer less than or equal to x. So 0, 1, minus 1. If I have a number supposing 0.5, what is the first integer on the left? 0. So box of 0.5 is equal to 0. If I have a number minus 0.5, first integer on the left is minus 1, so this is equal to minus 1. And box of an integer itself is the same. Okay. So the first integer that comes on the left will be the value of box x. So if anyone asks you to integrate box x 0 to 2, what you need to do is you need to break it down into intervals where I know the value of box x. So between 0 and 1, I'll get a fraction. So between 0 and 1, if I have any number here, box value will be 0. So box value will be 0. Between 1 to 2, similarly, between 1 to 2, any value of x if I have, first integer on the left will be 1. Therefore, the value of box will be 1. So this is how you deal with box x. You break down the interval into the intervals where you know exactly what will be the value of box x. So you do that. Okay. So similarly, if you have from 0 to 3, supposing, you'll make another 2 to 3 2dx. That's it. It's as simple as that. That's how you deal with box x. Right? It will get a little more complicated if you have a integration 0 to 2 box x square dx. Okay. So this limits is for x, not for x square, right? So these limits are for x, but I have box of x square. So what will be the value of box x square? If box x square is equal to 0, that means that x square has to lie between 0 and 1. If x square lies between 0 and 1, that means x lies between 0 and 1. So from 0 to 1, it will be 0. Please understand, box x square will be equal to 0 if x square will lie between 0 and 1. Similarly, box x square will take the value 1 when x square will lie between 1 and 2. That means x has to lie between 1 and root 2. So I'll write this as 1 to root 2 1 dx. Please try and follow this. This was the simple box function. This is the more complicated box function, wherein box x square dx, I was able to write it down in this way: from 0 to 1, when x is lying between 0 and 1, x square will also lie between 0 and 1, and box x square will take the value 0. X square lying between 1 and 2, box of it will take the value 1, but x will take the value between 1 to root 2. Try and follow this. Similarly, x square lies between 2 to 3, box x square will take the value 2, and x will lie between root 2 to root 3. Last but not the least, x square lies between 3 to 4, box x takes the value 3, x lies between root 2 to root 4, which is 2. So if I have integration 0 to 2 box x square, I will be able to write it down in this particular fashion. Okay. Right? Okay, so this is integration of box function. Next, double integral. Double integral. So integration, some function of x, some function of y, dy dx. Okay, so you can write this in this way: fx okay, so you integrate firstly with this part, then this comes out, and then you integrate the entire thing with respect to dx. or vice versa. Normally, it does not matter which one you integrate first, but you have to be smart about it, thinking which integration will be easier to solve. That's all. Okay, we'll be doing one problem of double integral today itself. Integration by partial fractions. This again we'll be doing today, wherein if I have a function like this, supposing today we'll be seeing this, we'll have supposing x into x minus 1 into x minus 2. So if I have to break this up into partial fractions, what I'll do is 1 by x into x minus 1 into x minus 2. I want to break it up into smaller fractions, not this composite fraction. So I'll write a by x, b by x minus 1, c by x minus 2, and then try to find out the values of a, b, and c by forming an equation. We'll be doing this in detail when we do the problem of partial fractions. Okay, I can also share with you which problem is it. It's ISI 2007 question 19. We'll be sharing with you how to solve it by partial fractions. For this double integral, it was ISI 2013 question 15. We'll be doing this as well today. Okay. Next up, gamma integral. This we'll probably do in the next class. Gamma integral is basically integration 0 to infinity e to the power x, x to the power n plus 1 dx is equal to gamma n. Okay, this is equal to gamma n. Yeah, this is n minus 1. It's, yeah, e to the power minus x, x to the power n minus 1 is gamma n. Gamma n is basically n minus 1 factorial. Okay. We've been using this concept in terms of, first we saw this concept in box function where we had some limits in the integration. This is called definite integral. So definite integral is when I have a few limits here. This is called a definite integral, when the integration has limits, and area under the curve is an application of these definite integrals. So this is an example of definite integrals. And this will help us in finding the area under the curve. How? So minus a2 plus a fx dx is basically, this is minus a, this is plus a. If I have a curve, the area under the curve is this value. This is the area under the curve. So in order to find out the area under the curve, minus a2 plus a fx dx, we do this. So this is area under the curve. Okay. We'll be doing a few applications today itself. Also, please remember, if they tell you to find out the area under the curve, this will give me a positive value. But if you have a curve like this between minus a to plus a, since it is below the x-axis, you will notice that integration minus a to plus a fx dx will come out to be a negative number, because below x-axis it will give me a negative number. Okay, so you have to be smart enough and convert this negative number into, supposing the answer is minus 8, convert this into plus 8, because this area is obviously positive. Area cannot be a negative number. What this means is that the summation of all the values here, integration is nothing but continuous summation. So summation of these negative values is equal to -8. Therefore the area is obviously +8. Okay, so this has to be understood. So whenever you find out area under the curve, it's a very good idea to draw the diagram, because if they tell you what is the area under the curve for a graph like this, between this value and this value, firstly the area will come out to be negative here, and then the area will come out to be positive. So if they tell you to find out the area under the curve and the x-axis, for this negative number you have to convert this into positive and then add it to this positive number. So you have to be smart about it. Okay, so this is what is area under the curve in integration. This is what will be used by us in the topic integration and all the questions that we do in integration. Although the application of integration goes far beyond the topic integration itself. So integration we will also use under probability distribution. Right? Under probability distribution, whenever we talk about a continuous distribution, for all the aspects like the distribution function, like the cumulative distribution function, which is basically probability x less than equal to x, we will use integration minus infinity to x fx dx, where fx is the probability density function. Okay, so we will be using integration in probability distribution as well. Okay, so that is the future thing when we go into the topic probability distributions. Right, the point being, please don't ignore integration. It's an extremely important topic. Okay.